Hi everyone, so this is our last section of notes here. We're going to finish up galaxies and our quarter. So galaxies are clumped in space, so usually galaxies occur in groups, and these groups are going to be called clusters. And the galaxies in a cluster are bound together by that force that holds everything together, gravity, and they also can collide, and we'll be talking about that a little bit later. But our galaxy, the Milky Way, is in a cluster called the local group. So these clusters and galaxies occur in bigger groups called superclusters. Most superclusters are not gravitationally bound units, and the like clusters are. So these are a little bit different. So clusters of galaxies make bigger groups that are not gravitationally bound. But all galaxies, all clusters are moving away from each other as our universe expands because of that law that we discussed earlier. So if we take a look at some clusters of galaxies, we can see a bunch of different types. We see a barred spiral over here. We see a spiral over here, an elliptical galaxy, all these different galaxies in a cluster. This is actually the Fornax cluster of galaxies here. So if we take a look at our galaxy, we can see that we're right here. Here we are. And our galaxy belongs to a poor, irregular, wimpy cluster. It only consists of about 40 galaxies, one of them being Andromeda, which is a really big one. And it's called, again, the local group here. So we see about all of the galaxies that we can see. Andromeda's over here in our cluster. So when galaxies collide, they're usually galaxies that belong to the same cluster. Sometimes these galaxies can pass through, and sometimes they combined. So the individual stars in the galaxy, since there's so much space between them, they do not hit each other. But the things that do collide are those huge clouds of gas and dust. So those, when they collide, make a large amount of new stars, which is why these colliding galaxies make a really big difference. But it's important to note here that these colliding galaxies, the stars within them, are not colliding, but those clouds of dust and gas are colliding there. So if we take a look at some of our colliding galaxies, we can see new stars are being produced here. We see the material going in between these two galaxies, and this tail. So pairs of colliding galaxies often exhibit large antennae of stars ejected by the collision. So we see some of the stars are going to be pushed out, as well as all this new star formation as those gas clouds and dust clouds combined. So if we look here, we see two galaxies that are kind of orbiting each other, and their gravity is distorting the different galaxies here. So you can see how this one is a bit flattened and not as circular as this one, and as they collide here. So our local supercluster and other local superclusters, our local group, which is again the cluster of galaxies that the Milky Way is a part of, is at the center of our diagram here. So if we take a look, our local group and our local supercluster extends out to the Virgo cluster, which is right over here. So we have a much bigger area within our supercluster than we do within our local group, our individual cluster. But you can see all of these different galaxies over here in different planes that are found within. So beyond superclusters, we see kind of a filamentary structure within the universe. And you can see here 1.6 million galaxies are shown in this image, which is an obscene amount of number. but you can see that all of these galaxies together kind of make it look like they're strings in a filament. So if we take a little bit closer look, this map has about 62,000 galaxies in these two wedges extending out from our galaxy itself. And we can see these different shifts in that dust figure here and how many galaxies are in distribution here. So we know that our universe is expanding. So the red shift of superclusters shows us this idea that the universe is expanding. So the red shift is called cosmological redshift because it is caused by the expansion of space. So the farther away a galaxy is from us, the faster it moves away. So we can see that by an example here. So galaxy speed is equal to the galaxy distance and Hubble's constant. So as that distance increases, we're going to see that speed increase as well. And this is going to be called Hubble's law. And we're going to go over this. So again, the farther away a galaxy is, the faster it moves. So if we take a look at our distance, we see a lot of clumped galaxies together over here at about 100. But as these galaxies move further and further away, we can see a couple outliers over here. The distance is also increasing. It's a linear connection between the distance and the velocity. So if we take a look at the galaxy from how far away, we can see billions of years that's happening here. So Hubble's telescope is going to look back to when the galaxy was very young. So we know that our modern universe is about 13.7 billion years old. But as we moved through this era, that's when we see all of these galaxies being developed here. So again, taking a look at all these different distribution of galaxies, we can see some spiral galaxies in here, again some elliptical. I'm sure there's some irregular in there that I can't point out to you, but all of these belong together in groups. And the further and further we move away, so this is 13 billion light years away, we can see there are still galaxies out there. So we know how far out that we're moving. So do all galaxies have spiral arms? No, only galaxies that are spiral or barred spiral have those spiral arms. Elliptical and irregular, you're not going to be able to see those. Are galaxies isolated? No, we know that they are grouped into clusters, and those clusters are grouped into superclusters. So everything's close to each other here. And are all other galaxies moving away from the Milky Way? All galaxies except those in our local group are receding away. So remember Hubble's law, the further you are away, the faster you're moving away from other galaxies besides the one in our local group, which are actually, ironically, moving towards us. So there's a little bit of a difference here. That's it for galaxies. Make sure if you want to watch those support videos that I posted on our Teams page, those are going to help with the comprehension of this material. If you have any questions, make sure you ask.